In this video, we are going to perform a 4-point IDFT, inverse discrete Fourier transform, using fast Fourier transform, that is DIT algorithm. For the following values, x of k is equal to 20 minus 4i, 12 and 4i. So the first step is, in addition to bit reversal, you have to perform complex conjugate value also. Complex conjugate value means if I have a minus I, means you have to take it as plus I. Okay, that is a plus j ib means you have to take a minus ip and vice versa. So you have to write here 20, 12, 4i and minus 4i. Okay, so if you substitute in this formula, so in this diagram, 20, 12, 4i and minus 4i. So if I add these two value, I'll get 32. If I add this two value, I get 0. If I subtract this two value, I will get 8. If I subtract this value, I will get 8i. So you have to multiply this 8i with minus I. So you will get 8 as your answer, right? So 32 plus 0 is 32. 8 plus 8 is 16. So if I substitute 32 minus 0, I will get 32 here. Then 8 minus 8. 8 minus 8 is 0. So once if you get the answer, you have to divide the whole term by 4. So if I divide the whole term by 4, I will get x of n value. So the x of n value is 8480. 8480. Okay. So now let us discuss another problem. So here they have given x of k is equal to 0, 0, 4, 0. Then we need to perform a IDFT. IDFT using DIT algorithm. So this is my background. So in addition, so if you see, they are given the value of x of, this is the value of x of k and this is the value of x of m. Okay. So in addition to the bit reversal value, so if I bit reverse this one, I have to write this one as 4, right? 4, 0 after taking bit reversal and complex conjugate. So if I add this one, I will get 0, 4. If I subtract this one, I will get minus 4. If I add this one, I will get 0. If I subtract, I will get answer as 0. Okay. Again, so if anything multiply with 0, I will get only 0. Right. So if I add this one, I will get 4. If I add this one, I will get minus 4. Okay. So 4 minus 0 is 4. Minus 4, 0 is minus 0 is minus 4. So if I divide the whole term by 4, I will get 1 minus 1, 1 minus 1. This is my answer. Okay. Shall we go for another problem? So the question is x of k is equal to 4, 0, 0, 0. Okay. So what is 4, 0, 0, 0? First let me erase this one. Four zero zero. Even if you take complex conjugate and bit reversal, you will get this answer only. So if I add, you will get 4. If I subtract, you will get 4 on 0 0. Okay. 4 plus 4 is 4. 4. 4 minus 0 is 4. 4 minus 0 is 4. So you will get answer as 1 1 1 1. This is for 4 0 0. Okay. So if I take inverse DFT, I get the value of x of n. So the x of n value is 4 ones. So now let us take this value 4 ones. Okay. So for 4 ones, even if we take bit reversal, the answer will be same. So let me substitute this value. So if I add, you will get 2. Subtract, I will get 0. This is same for this one. So if I add this two value, I will get 4. If I add these two values, I will get 0. So 2 minus 2 is 0. 0 minus 0 is 0. So if I divide this value, I get the answer as 1, 0, 0 and 0. Okay. Shall we go for some other problem? And let me take x of n is equal to 1, 0, 1, 1. Okay. So they asked to find the value of x of k. Okay. So you have to take the complex, a bit towards the value. So this is my answer. So if I add, I will get 2. If I subtract, I will get 0. So if I add, I will get 1 and this is minus 1. Okay. X 2 plus 1 is 3. 0 plus I is I. Okay. Then 2 minus 1 is 1. Then 0 plus I is I. Minus I. Okay. So the answer is 3, I, 1 and minus I. So suppose if I am giving this value to here, this value here, okay, in order to perform the IDFT, okay, this is 3, 1 minus I and I. So if I solve, this is 4, this is 2. Here, if I solve, I'll get 0 and this is minus 2i. So we'll get the answer as minus 2. Okay. So here, if I solve 4 plus 0 is 4. 2 minus 2 is 0. Right. Then 4 minus 0 is 4. 2 minus 2 plus 2 is 4. So we'll get the answer as 1, 0, 1, 1. This is my x of k value and this is my x of n value. So after dividing the whole term by 4. Yes.